So let's look at what would happen if you try to predict y using x when x and y are not correlated. So we're going to look at the situation of what happens if you try and use regression when x and y have a correlation equal to 0, or at least statistically equal to 0. All right, so if the R value, correlation, if the R value between x and y is 0, or statistically equal to 0, the best predictor of y is y bar for any x. Regardless of what x equals, you should always predict y to be y bar, the mean of y. And I'm going to explain this now. All right. What you're looking at here is a whole lot of nothing, right? There is not much pattern to these dots. They all appear to be helter-skelter. In fact, if somebody said, Lynn, I want you to draw a line, you decide if it's going to be a positive slope or a negative slope, I would be hard-pressed to try and figure out which way it should go, right? And in a situation like that, I know that there is essentially no correlation between x and y. If I can't figure out how to draw the line, there's no correlation between x and y, no linear correlation. Okay, so in a situation like that, what did I say? You should always use y bar for your prediction. So what we're going to do, and in fact the equation will do this for us, we don't actually, remember we never draw the line by eyeballing. There's a formula for this line. So what we're going to do is we're going to draw this line, and guess where this line is going to start? It's going to start right here. This is the mean of y. So what is that, about 12, right? So the line is going to start right here, and it's going to be a flat line. Now, this line is not perfectly flat. This is actual data. And so we didn't actually get r equal to 0 precisely. So there is a very, very tiny slope here. But what I can tell you is that this slope, which is a very, very slight negative, this slope here is statistically equal to 0, right? There is no slope, statistically equal to 0. Okay, so why are we drawing it at y bar? Why is it the case that no matter which x you use for your prediction, you should just tell me y bar? All right, so if I say, okay, x is 5, I want you to predict y bar, you should say 12. When x is 15, predict y. You're going to give me y bar. You're going to give me 12. When x is 20, all right, what is y prime? You're going to give me 12. You're always going to say 12 because 12 is the mean of y. Okay, so let's explain this. One of the assumptions of correlation, which happens to be the same assumption as for regression, is that x and y are normally distributed. Okay, when we're talking about linear correlation and linear regression, the assumption is x and y are normally distributed. So that means that these are the y values, and I had to draw the distribution on its side here because, it's on a y vertical axis. But what we're saying is that these values here of y are normally distributed. Well, if that's the case, what would be the most frequent score? Well, it would be the mode, right? But where is the mode? Right smack dab in the middle. All right, which score cuts the distribution in half? Well, that would be the median. Where's the median located? Remember we learned about this early on? The median would be right smack in the middle because it divides the distribution in half. And if it's perfectly normally distributed, then it means this half is a mirror image of that half, right? It's perfectly symmetrical. And what else did we learn? Well, if it's true that it's normally distributed, and we're going to assume it's perfect, then the mean is also right smack dab in the middle because the mean is the center of gravity, and it would perfectly balance the weighted scores above it with the weighted scores below it, right? So this is, if you put the mean here, it's going to be that seesaw fulcrum. It's going to balance the scores perfectly. So if there really is no relationship between X and Y like here, then I'm asking you essentially to make a guess, right? Guess Y. I mean, guess the variable Y. Guess that variable. What does Y equal? Well, your best guess would be to give me the most frequent number. Knowing that it's normally distributed, give me the most frequent number or give me the mean. Because if it's normally distributed, the mean and the mode are going to be the same number, right? Mean equals median equals mode in a normal distribution. So the best predictor of Y, regardless of which X you look at, is going to be Y bar. Right? Oh, finally, we filled in what was missing here. All right. Y bar is the mean, median, and mode for this set of data. So if knowing X tells you nothing about Y, your safest bet is to just use Y bar. Okay? And that's why it's a flat line, because Y bar doesn't change. No matter what X equals, Y bar doesn't change. You're just going to say Y bar, Y bar, Y bar. For every X, you're just going to say Y bar. Okay? And again, it's not perfect here. There's a little bit of a slope because it's real data. But if we were to actually test to see if there is a significant difference between this slope and 0, we would see that it's not significantly different from 0.